Today we're going to be talking about section 8-2, and we're going specifically over factoring using the distributive property. Okay, if you're on page 426 and you're looking at that section, what you'll notice is that the section in the book does not match up to what we have on the calendar. So be very careful if you're looking at the book. Our calendar is a lot different for this chapter. It doesn't match up exactly. Okay. So going to do a little bit of review first. Okay, recall when you're multiplying two numbers together, what you get is a product. Okay, so I want to go over some vocabulary. You have your factors, the numbers that you multiply together, and then you have your answer, and that's called the product. And this is the same if you were looking at monomials or binomials and polynomials. Say, for instance, we're multiplying together 2a times the binomial 6a plus 8. Okay, the 2a is a factor, the 6a plus 8 is a factor. What do you think the product would be? Okay, the product would be, as you may already guess, what you would get if you multiply 2a times the quantity 6a plus 8. And when we multiply, you're looking at this, you might remember that we need to distribute. Okay, so let's distribute and multiply our polynomial. We would get 12a squared plus 6a as a product. Okay, so we have factors and products. Okay, so the act of factoring, which is what chapter 8 is all about, is going in reverse. We are going to start with a product and we're going to back our way into determining what the factors would be. Okay, so factoring a polynomial means finding the factors that make up the polynomial. Okay, and some people consider this reverse distributing. You're distributing but in reverse. Instead of multiplying in, you're dividing out in order to get your two factors. Okay. There are a number of methods in order to factor. There are different ways you can go about it. You can use the GCF or distributing property, which is what we are going to talk about today. You can use what you know about dots. You can use PSTs, you can do grouping, or you can use a strategy called Xbox. Okay, so with each video we are going to be covering one specific method. Okay, so today we're talking specifically about GCF or distributive property. Okay, so let's start with that. Method 1, using the distributive property. Okay, so let's take, for example, this binomial. Okay, this is a polynomial, and what we want to do is we want to break it out to two factors. Okay, so we're going to take a look and we're going to find the GCF in order to find out what's in common. What do these two terms have in common? Okay, if you remember from the last video, you can find the GCF by using the factor ladder. Okay, so if I set this up, what I first notice is that 15 and 25 have 5 in common. It also has an x in common. It also has one y in common. Okay, and when I took out the y, I'm looking at 3x, y, and 5. There's nothing left in common, okay? Remember, this is the binomial that we started with, okay? What we're doing is we're slowly taking out pieces that they have in common. At the end, we still have this binomial, okay? These will form our two factors. Okay, so our first factor is our GCF, 5 times x times y, and our second factor is our binomial. So let's take a look at what that would look like. I have 5xy, our GCF. Okay, so I write that's our GCF. And you have what's left over, your remainder, so to speak. Okay, so The neat thing about factoring using GCF is that you can check your work to make sure that you have the correct factors. Well, let's see. They don't have anything left in common, so what I can do is I can multiply back in. Let's distribute the 5xy and see if it checks. 5xy times 3xy will give me 15x times x is x squared, y times y is y squared, plus 5 times 5 will give me 25, and I also have x and y. Okay, and let's see if our factors were right. Going back to where we started off with, it does match up, so it checks. Okay, so when we are factoring, we're looking for the two factors that make up our product. Okay, so these two factors would be your answer. Okay. Another method you can use, and go through this. Another method you can use is the box method. Okay, so let me get that paper ready. The box method, and this is still using the distributive property or reverse distributive property. If you have a problem like this, this is a product that we want to factor, what you can do is put it in a box. Okay? And with problems like this, it's actually really easy to notice what each term has in common. You know that between 8 and 24, your GCF is going to be 8, right? Because 8 goes into 8. 8 also goes into 24. Okay? Well, what else do they have in common? They have the term B in common. They also have 1C in common. Okay? So now what we're going to do is we're going to go backwards. We're going to say, well, what would I multiply to 8BC to get 8BC squared? Okay? So that means what's left over? Well, 8's already accounted for, 1b is accounted for. Well, there are c squares here, there's 1c here. That means we need to multiply this by a c. Okay, let's take a look here. If we factor out an 8, we'll have 3 left, and that's a positive 3. Okay, a b's accounted for and a c's accounted for. So, and this would be here our binomial. This would be our monomial. They're both factors of what we have in our box. And of course, we can double check. Let's take 8bc multiplied by c plus 3. Okay, 8bc times c would give us 8bc squared, plus 8bc times 3 would give us 24bc. It matches up to what we started off with, so that checks. So this would be our answer. This is the factored form. Okay. All right. So what I'd like for you to do is to try this problem. Okay, you can use the factor ladder or you can use the box method. Either way, what you're trying to find is the common factors between all three terms. Okay, did you get it yet? What I noticed is that, well, they don't all have y's in common. They only have a common factor in the coefficients. 12, 9, and 6 all have a common factor of 3. So if you're using the box method, I can put all this in a box. I can only factor out a 3, which means I still need a 4y squared in order to multiply together to make that work. I would need a 3y here, and I would need a positive 2. So my factors would be 3 times the trinomial here. Okay, did you get this? Okay, if you did, give yourself a star. And of course, you can always check your work 3 times 4y squared gives you 12y squared. 3 times 3y gives you 9y. 3 times 2 gives you 6. Okay? All right, so let's see. I'd like for you to do this problem set on page 427. Do the problem 1A and 1B. And then on page 429, do problems number 1 and number 2. Bring these to class tomorrow and we'll talk about them